Okay. Let's review a little information about constant proportionality. As a reminder, constant proportionality is a set of data that has all the same proportions. They have all the same proportions. When you have a table, you can cross multiply, and one side's always going to equal the other. Constant proportionality has a little k that's used. Can be found by interpreting a graph or interpreting a table, written in an equation, or can be found looking at a graph. And there are three ways to find the constant proportionality. We have been doing constant proportionality, I feel like, forever. So this is a good way to remember it. On a table, remember you want y divided by x. Sometimes you look at it as a fraction. Sometimes you look at it as a decimal. Sometimes you look at it as a fraction. Sometimes you look at it as a decimal. What is my constant proportionality for my table? Say it again. 7 divided by 2. And I like how she used the 2 that don't have a decimal. Do you guys like dividing decimals? No. What is 7 divided by 2 as a decimal? Say it again. 3.5. You will see it written either way. 7.2 or 3.5. If you didn't know how to get to 3.5, 7 goes on the inside, 2 goes on the outside. 2 goes into 7 3 times. 3 times 2 is 6. 1 left over. Add a decimal, add a 0. 2 into 10 goes 5 times. What is my constant proportionality in the equation? Yes, ma'am. 8. Remember your equations. Y equals kx. So you're looking for whatever number is attached to the x. You're looking for whatever number is attached to the x. Guys, I need to see calculators on your computer if you have your computer open. Right now, we don't even need the computers really. But I'm seeing way too much not math stuff. On a graph, remember it has to be a straight line and it has to go through 0, 0. It has to go through this origin. What is my constant proportionality here? Somebody other than Aubrey. What is my constant proportionality here? 3. You can do this 2 ways. You can go up and then over to where it crosses a line. I went up 3 over 1. Because remember, y over x. Going up is your y, so that is 3. Going over is your x, that's 1. Or I can find my point, which is 1, 3. X is your first number, y is your second number. This one here is 2, 6. 6 divided by 2 goes down to 3. Do you guys have any questions? Yes, sir.
Where did going up to 3, going up to 3, and then also
Where did that come from? Okay. Here's your axes, right? Y is your vertical, x is your horizontal. If constant proportionality is y over x, your y is your up or down number. Okay? Your x is your left or right number. This is slope. You will be doing slope. I can't tell you how much next year. Okay? Being honest with you. So, your 3 was on the y. It went up, so it's a positive. You went to the right, which is your x. You went to the right, it's positive. So I'm showing you a little bit of slope ahead of time. Okay? any other questions? Okay. So let's flip this over. Is that okay? Oh, the smaller the constant proportionality, the smaller the constant proportionality, the smaller the unit rate. Unit rate and constant proportionality are pretty much the same thing. If it's a small constant proportionality, it's going to be a small unit rate. If it's a large constant proportionality, it's going to be a large unit rate. Braxton, sit up. Good. Let's look at this. CJ, Holland, and Brandon all race together. Below shows your speeds. Who has the fastest speed for the race? How do I figure out the fastest speed for this race?
So you would take each of them and find the constant proportionality.
I have to find the constant proportionality for every one of these. Okay? So let's start with the easy one. What's my constant proportionality for Holland? 6. What's my constant proportionality over here for Brandon?
8.
Let me grab the bigger one. It's 7. I know why you say it's 8, but it's 7. Okay? You can barely see, but there is a line right here. If you come up and over, this is 7. Okay? So what's my constant proportionality for CJ? What do I have to do here?
You do y over x equals 13 over 2 and get 6.5.
Okay, can I hold there for a minute? The way the numbers are right now, I have 13 over 2, 6, and 7. Can I compare them the way they're written right now? Yes or no? No. What do I need to do with that 13 over 2? Change it to a decimal. To compare, make everything decimals. To compare, make everything decimals. 13 divided by 2 is 6.5. 13 goes on the inside, 2 goes on the outside. So who has the fastest speed here? Brandon.
No. In a race, you want to get the least amount.
Huh?
In a race, you want to get the lowest fastest.
When you're running,
Oh, it's mine.
miles per hour. So when you're running, you want to go the most miles per hour. Who's the slowest? Holland. Are there any questions? Okay. The following represents the cost of a hamburger at 3 different restaurants. Somebody other than Aubrey, what's my cost of one hamburger here? What's the cost of one hamburger here? Say it again. $1.20, 25 cents. Okay, 5 over 4, which is going to be 1.25. 5 goes on the inside, the 4 goes on the outside. What is this one going to be? 7 over 2, which is what as a decimal? 3.5. What about this one? I'm going to go up and over. What is that one going to be? 2. So which one has the largest constant proportionality? Hormones. Who has the cheapest hamburger? Smith's. Do you see how it doesn't always have to be written out in words like what we did yesterday? You can use graphs and tables to compare things. Okay. The following are results of a swim meet. So they were swimming meters per second. Who swam the fastest, or who swam the slowest, who swam the fastest? What do I need to do here? Tyler's going to be 6 divided by 4, which is going to be what? 1.5. What is Aubrey? What is Coyote? And I'll give you a bigger picture here. Is that 1.5? No, that's like 1.25, right? So who's the slowest in this case? This one. And then who swam the fastest? Tyler and Aubrey. They must have tied. Do you see how we can use constant proportionality and compare things just like what we did with unit rates yesterday? Do you guys see that? Okay. You are gluing this on page 58.